Tenny is a seasoned technology professional with over a decade of experience in designing, securing, and testing computer systems for diverse industries, including banking, fintech, healthcare, and media. Tenny is passionate about mentoring and collaboration to foster the development and advancement of teams he is in. As CTO of Cognidec, a technology consulting firm, he is responsible for technology strategy, design, and implementation. Today, he will be speaking about security mindsets for developers.
We're just going to go right into it. I'm going to be sharing my slides. So I'm going to be talking about security mindsets for developers and generally for anyone. It's very important to have mindset, the security mindset, because we have this, view about the world, especially when we start out building stuff, hoping that people will like it and use it. Sorry, I have just clicked the wrong button. Should be doing slideshow. Okay. All right. Okay, so this is the summary of the talk. So whose job is it to do security? And when does security become important? And what mindsets and tools will be helpful, to improve our security posture as developers? Okay, so generally, the idea is not to view these kind of talks as boring, security lectures you have to sit in maybe to tick the box for compliance reasons, but to actually adopt this mindset, so that the systems we build, the users that use the system can be all kept safe. Right. So whose job is it to do security? Yes, the regular trainings, ISACA, CISSP, and all those bodies of knowledge will say that the responsibility falls ultimately on the executives and board of directors, like top level. If an application or a platform is vulnerable, then the CEO and the board of directors are held, accountable. And ultimately, that's how it should be. But you have a role to play. I have a role to play in ensuring that the security posture is always upheld and kept, the way it should be. All right. So when does security become important? Now, that's the answer. Now, and now meaning at every point in the life cycle of our product development, in the life cycle of our projects. So gone are the days when we get the application ready and then say, okay, now it's time for the security team to take a look at it. From the ideation phase, when you're coming up with what you want to build, what the products are going to be like, what features we're going to have, the question should always come up: when this feature is ready, would it be secure? How do we secure this particular feature, this part of the application? So security is important now, and it will continue to be important even when the application is deployed and we're in the maintenance phase. Okay. So, like I said, your security hat needs to be on, and it needs to stay on from the start of the project all the way to the end. All right. So what are the security mindsets, that we need to develop? And we'll go right into it. So Hello World is the, how you're baptized into the world of software development. You pick a new language, you learn maybe JavaScript, Java, Python, C++, whatever it is. And the first thing you want to do is write Hello World. And it's so exciting, right? I could, print something to the console. But from that excitement, and usually this happens in areas that they call playgrounds. You put Java playground or play area where you can, write code on a web browser or whatever your IDE. And you should quickly transition from that mindset and that excitement of oh, I wrote hello world and it works, to war zone, meaning I am in a war zone. And you may not believe me, but I'll prove it that it's a war zone out there. So this is what the world looks like. There's a tool called NetScout, and you can see in this visualization a cyber attack map for DDoS, which is distributed denial of service attacks. And you can see where those attacks are originating from and where they're heading. This is the world that we're in. And this screenshot was taken just before this talk to make it fresh. So what does this mean? There are vulnerable systems, vulnerable Internet of Things devices that attackers have literally made zombies. And it's when they are needed, they now begin to make attacks against systems that are targeted. And so this is why it's so important to pay attention to security. It's very easy to say, well, it's just a camera, I connected it to the internet, it does nothing. But what if it's taken over by some person in an enemy state and there are 100,000 of those devices? And if all the traffic is now targeted at some system, you would need some advanced way to deal with that. Okay, so this is what the world is like. There's another tool, Gray Noise. Gray Noise gives you a visualization of current exploits that are, happening, and you can do a search, and you can submit tags. So, for example, you have CVE. CVE stands for Common Vulnerabilities and Exploits that are being exploited actively, and you can see where the traffic is from, what the IPs are. So this is exactly what's happening and what the world is like. So gone are the days when you have just a tool and you share it, you're excited about it and hope that everyone, will be excited with you and use it, legitimately. It's a crazy world, it's a war zone. Okay, so that's one mindset. So like I said, don't say I have nothing of interest in my system. The system might be turned into a zombie and used for a denial of service attack. Okay, so the mindset to adopt is to say an attack is about to happen, an attack is happening, or an attack has just happened. So you must always be on the edge. You must always be expectant of something, that is going wrong, because that's the world that we live in. Okay, so we move to the second mindset that I want to talk about, and that is shift left. What do we mean by shift left? Okay, so attacks have, or bad actors can no longer wait. So they can't even wait for your systems to be ready. In the first talk, Kingston was talking about Python packages, which means they go and plant certain vulnerable codes or backdoors or be able to create a reverse shell. And what that means is we'll wait for you so that when you come and use these libraries mistakenly, of course, you would have that in your system, and then we can have access in the future. So those kind of attacks are called supply chain attacks. Anyone who does JavaScript development will know that we usually do an npm install. We go to the registry to get all kinds of JavaScript packages or libraries that we can use to develop our codes. But what if there was a typo? There's something called typo spotting, which means someone knows that the library you meant to install was React. But what if I spelt my React with a double T, hoping that somebody will make that mistake? And then it's installed on your system. And then there are all kinds of things installed on your system. Okay, so that's what we mean by shift left. So don't wait for security to be implemented at the end of the life cycle. Go look at the whole thing holistically, and from the beginning, begin to incorporate security policies and protective measures to ensure that we stay safe. There are rogue pipeline plugins. And what do we mean? These days, it's common to have a CI/CD pipeline for ensuring that our builds and deployments are more effective. So there are plugins that need to help convert or do some interpolations or bring in certain things that we need to get those tasks and take them through those deployment stages. So plugins could be vulnerable. It could be sitting there waiting on the pipeline to inject vulnerable code. And so we need to be careful of these. So it's common to have a dev and test and a staging environment. Of course, the dev is where the developers play, they develop and they can test their code. Test might be just to test things, and staging could also be where you give QA, to do their own tests. Now, it's common to leave the dev and test and staging environments as insecure, or maybe leave them on debug level, or leave them, in a state or in a version in a way that makes them less insecure, and to just shift all the focus to production environments. But the dev, test, and staging usually mirror production. And so whatever levels of security or controls you implement for production, you should implement them for dev, because those are your systems. Okay. And proper inventory of these systems will help, so that you don't leave some environments just running and then nobody knows what those environments are for. Okay, so we'll move on. Now, to confirm what Kingston was talking about in the first talk and what we're talking about now, this is a platform, a tool, Snake. The tool helps to check most of these supply chain vulnerabilities. And they found 200 plus malicious NPM packages. And the article is listed, below. So in case you want to read more and learn more about this. Okay. So we talked about this. Build security into your pipelines, scan container images, even if you're the one that baked them. There are tools like Trivi that you can use to scan your container images. Early EDR on dev and staging environments, so that you can know what's going on your systems and VMs, and early documentation. We have, versions of APIs changing in such a way that no one knows, or no one even wants to change those things, because there is no documentation. And so people just leave those things like that running, and vulnerable or weaker access controls might exist in those versions. So it's important to take care of those. Okay, number 3, this is my favorite. Secrets should stay secret. We have a way of developers of dealing very terribly with secrets. And I'm going to show examples here. Okay, so look at this, and I will challenge anyone on this call listening to this talk, to go into GitHub and do a search for API key, and you'll be shocked at the keys that will come back. And so I've titled this "GitHub Knows Your Secrets," and it's telling it to the world, right? So here you can see, I just tried to, blow out or hide some of the secrets, but these secrets will give you access to systems, will give you access to a Mongo database. There are a lot more. I just could only fit these on the slides. So there's the correct way to deal with secrets. There are secret managers. There is Azure Key Vault. There is the secrets manager in GCP. So your secrets shouldn't go into version control. And we keep saying this, but it keeps happening. This was a search from today. So this shouldn't be happening. Okay. Now, another one we see is mobile apps. Mobile apps can't keep a secret. You can't put login credentials or API keys in mobile apps. No matter what platform you're using, they can be reverse engineered. In one client work we were doing recently, we reverse engineered the app, and we saw access credentials inside the app with user details. Okay, so pay attention to that. Mobile apps, React apps, Angular apps, you cannot keep secrets inside them, because you are handing those apps to your users. So you need to be very cautious of that. Okay, so an example in our tech ecosystem is Tesla. And this happened a while back. They had a Kubernetes cluster running, and they had a pod in Kubernetes. For those who use Kubernetes, you know that we run pods to actually run some compute within the cluster. And they had a pod that was exposed. And this pod exposed some credentials that gave access to an AWS bucket where they could see Tesla car telemetry details. And they eventually used the pods to actually mine crypto on the Kubernetes cluster because of that vulnerability. You can read more about it in the article, in the link below. Okay. So validate everything. So this should have been 4. An error on the slide, we'll correct that. Validate everything and trust no one. Okay, so he was talking about validating input from users. He demoed an XSS, stored XSS vulnerability in the app. So it's very important. Do not trust your users. Do not trust the input from your users. And also responses from APIs. This one is uncommon. So you are, making a call to a trusted third party, be it your payment processor, your bank, or some verification platform. So think about it as a developer. What if that verification platform was hacked and it started responding with scripts or with injection? So don't trust, even though it's coming from a trusted third party that you're integrating with. Don't trust OpenAI. Don't trust ChatGPT's API. Don't trust Claude. Validates all the input because it's input into your system. It's responses that you're showing to your users that you're processing that you're going to work with. So make sure you accord the same level of validation to responses. So trust no one. And this also goes with the layered defense in depth where you are applying security to the different layers. So don't say, I'm just on an internal system. I'm talking on the same subnet or within a private network. Encryption is still important, provided things are in transit, encrypt, provided they are at rest, encrypt, and do the same, implement the same policies, because we don't know. An attacker might be inside. An attacker might be implementing a request forgery, a server-side request forgery that has granted him access to come into the system, into a private system. So you want to make sure that you are validating everything and trusting nothing. So it's called zero trust, like we know. Okay, so it's a war zone. Keep your ears to the ground. And what does this mean? Keep abreast of every happening, within the ecosystem. So we have OWASP. OWASP was talked about. They are doing amazing work, coming up with the top 10 lists of vulnerabilities for APIs, for apps, for LLMs. LLMs have become popular now. So read, keep abreast of what's happening. And that's how you can stay on top. Read security blogs. They're popular ones. You can find other ones online. Okay, so think like a hacker. So in this field, paranoia is good. So yes, they're out to get you, and that's the mindset that you should have. So ask yourself, how would I exploit this? How would I exploit this application if I was an attacker? And constantly have that mindset, because an attacker is trying to do that and thinking about that. Okay, and then be a lifelong learner. There's no one degree, no one course, no one certification that will do it for you. You have to keep learning and stacking up that knowledge, because the attackers don't stop. Where you have to, for the attacker to succeed, he just has to get it right once. And for you to be in a terrible place, you just have to get it wrong in one thing. So it's important to be a lifelong learner. So thank you for listening. And I'll be happy to take questions. My LinkedIn is here. Anyone who would like to connect, you're free to do so. The slides will be available. Thank you again.